Good evening, everyone. I'm Riya, a PhD Prime Minister's Research Fellow from the Department of Civil Engineering, IIT Roorkee, and we are having this session for the discussion of your previous year assignments for the week 1 of NPTEL course, that is Air Pollution and Control. And in this class, we'll be discussing the assignment for week 0 and week 1. We'll take that questions. Apart from that, we can also take your doubts that you are having with the subject. So I guess I can wait just for a few more minutes, 2-3 minutes, and then I'll start the class. Until everyone else joins the class, just wait for 2-3 minutes more. Okay, since I guess everyone will be quite late, so I'll just start the class now and let everyone else join the class as and when they come. So, hello everyone. Just a sec. Okay, so I hope I'm visible. So, the course is air pollution and control, and in this topic, we'll be covering different types of pollution. There's different types of pollution emitting sources, what are short-term and long-term effects, effects on different types of like human beings, effects on animals, effect on vegetation, effects on buildings and environment. Apart from that, we'll also be covering the air quality modeling concepts, indoor air quality, emission inventories, and then source and receptor based modelings, source apportionment studies, and in the I think in the last week we'll also be taking some lab assignments as well. So let's begin with today's session. So later in this lecture, what I've done is I've just compiled all the questions for the week 0 and week 1. Those were the objective questions that were given in the past year. So I just took those questions and I'll discuss those questions. Those are the objective questions. I'll try to discuss those questions, and if there's any kind of concept that is needed to be discussed, I'll take that also. So coming towards the first question, which of the following gas is maximum in percentage in the air? And the options are oxygen gas, nitrogen gas, water vapor, and carbon dioxide gas. So let's have a look about the composition of the air, because for telling this answer, I think first we have to look into the composition of the air, which is like this only. So we have just a second. Okay. So the composition of air is somewhat like this only, which is 78% of nitrogen, oxygen is 21%, and carbon dioxide is 0.04%, such a lesser amount. 0.04% is carbon dioxide, and the other gases, for example, argon, neon, xenon, something. So those are 0.96%, and this is mostly argon. So I think the question is maximum. So maximum will be your nitrogen. Nitrogen is, since it is 78%. So the answer will be nitrogen gas. Now coming towards the next question. In 1984, Bhopal gas tragedy was caused due to the leakage of which of the following gas? Sodium monoxide, sodium thiocyanate, potassium isocyanate, and methyl isocyanate. So let's have a look about this tragedy that occurred in 1984. Basically, it was the worst industrial disaster that happened till in the history. And I think on the night of 3rd December 1984, uh, basically there was a leakage of methyl isocyanate gas in the insecticide plant that was owned by the Union Carbide Corporation in Bhopal. So the leakage of that gas led to the deaths of thousands of people, and many were severely injured as well. And what happened in the leakage was initially the gas was confined in the factory or the industry region only, but then slowly it drifted over the densely populated neighborhoods around that plant, and this led to the deaths of thousands of people, and others. It also created a situation of panic among the others, and the final death toll was estimated to be around 15 to 20,000, which is a huge number. So, coming towards the answer of this question, it will be methyl isocyanate. Now, for the next question, which of the following is a secondary pollutant? So, as we all know that we have two types of pollutants in the atmosphere. First one are the primary pollutants, and the second one is secondary pollutant. So, just quickly, we'll have a look into the differences or the variation between the primary and the secondary pollutants. So, for the primary pollutants, basically, their emission is direct from the source. The primary pollution pollutants are directly emitted from their sources, and while the secondary pollutants have an indirect emission. Basically, secondary pollutants are formed when the primary pollutants disintegrate or react within themselves to form a new compounds. Then they are termed as secondary pollutants. Then the effect on living things, basically primary pollutants have direct as well as indirect impacts. How that indirect impact happens, basically the indirect impact is the primary pollutants transform themselves into some other complex compounds or some other harmful compounds, which led to the indirect impacts, while the secondary pollutants mostly have the direct impacts. Primary pollutants are comparatively unstable, which is why the secondary pollutants are formed. And these secondary pollutants are comparatively stable in the atmosphere. The direct target of the primary pollutants are living organisms, and the secondary pollutants have an impact on the ecological system. So, how to reduce the primary pollutants? Basically, source reduction or the low anthropogenic emissions. This is the best way to reduce these primary pollutants, because the source control methods are the best one, rather than processing the air, or after their emission we try to control them. The best way is to control the emissions and lead to the lower levels of emissions. This will definitely reduce the level of primary pollutants. Then we have for the secondary pollutants, how to reduce them. So compare as compared to the primary pollutants, these secondary pollutants are difficult to reduce. One way is, I guess, to control the primary pollutants. This will also lead to some of the reduction in the secondary pollutants as well. So the examples of primary pollutants are particulate matter, carbon monoxide, SO2, NOx, VOCs, and heavy metals, etc. For the secondary pollutants, we have ozone, peroxyacetyl nitrate, acid rain, enrichment compounds, and suspended particulate matter, etc. So the question was, which of the following is a secondary pollutant? And definitely it will be ozone. Now coming towards the next question. AQI stands for, what's the formula of AQI? If you're studying the air pollution problems or the air pollution concept, then this term is very much relevant, because AQI basically it stands for the air quality index. And this is basically a kind of scale that is used to gauge the air pollution. Basically, like we need some kind of scale. For example, if you want to measure the height, so we'll either measure in meters or in feet or in inches or something like that, because that is a kind of scale to have an understanding about the that particular quantity. So for having the understanding of this air quality or the pollution that is there, so we have formulated this index, and this is known as air quality index. So basically it comprises the effects of all the kind of pollutants, or the major pollutants, these are which are termed as the criteria pollutants. So it has clubbed the impacts of those pollutants, and we get a certain numerical value, and then we have bifurcated those values or set up standards for those values. Um, like the limitations, like it is bifurcated from 0 to 50, then 51 to 100, then 101 to 150, and so on. And as per those values, we have the levels of health concern. Like for example, if the value of air quality index is between 0 to 50, so we consider the air quality as good. We don't have to worry about that much level of pollution, and the air quality is considered as satisfactory, and air pollution poses little or no risk. Then if it is 51 to 100, then we have moderate levels of health concern. The air quality is acceptable. However, for some pollutants, there may be a moderate health concern for a very small number of people who are usually sensitive to air pollution. Then 101 to 150, that is, it is unhealthy for the sensitive groups. What do we mean by these sensitive groups? Basically, people who are somewhat allergic to some kind of pollutants, or the small childrens, or the senior citizens. These are the people who are sensitive towards the air pollution, and they may experience, if the value of AQI is between 101 to 150, then they may experience some health impacts. And if this value is 151 to 200, then the level of air quality is unhealthy, and I think everyone may begin to experience some kind of health impacts, and the members of those sensitive groups may experience more severe impacts. And if it is more than like 201 to 300, then it is very unhealthy, and some kind of health alerts may be given as well. This situation can be seen very often in the Delhi region, because they are for example, few months back, I guess, in the winter season, they have given health alerts, and everyone was wearing masks and trying to like stay indoors, avoid traveling, because the air quality was very unhealthy at that time. And if these values are more than 300, then I guess the air quality is hazardous, and the emergency conditions are there, and the entire population is likely to be affected. Now we have the AQI category, pollutants and health breakpoints. Basically, this is the range of the level of this is the range for the emissions, or how do we say, for the concentration of pollutants in all the categories of AQI range. For each of the pollutant, we have PM10, PM2.5, NO2, O3, carbon monoxide, SO2, ammonia, and lead. And for all the type of AQI categories, which is good, satisfactory, moderate, poor, very poor, and severe. So this is the range. This table, you can just have a look at this table, and it will be appropriate to just have a basic idea about these ranges. Now, coming towards the, I think we have answered this question. Yes, definitely. So, coming towards the next question, the value of the dry adiabatic lapse rate is, okay. So, the options are 9.8 degrees centigrade per kilometers, 13.8 degrees centigrade per kilometer, 5.8, and 8.8. So, this answer will be 9.8 degrees centigrade per kilometer. But just answering this question isn't enough. We should also know about this term. What is this dry adiabatic lapse rate, or what is this adiabatic process? Or what, basically, let's start from the lapse rate. What is a lapse rate? So, I guess lapse rate, let me term well, lapse rate, LR. So, this is equals to the variation in temperature, like the as we move. That is okay. So this lapse rate is basically what is there, T2 minus T1 divided by Z2 minus Z1. So what are these T2, T1, Z2, and Z1? So basically, let us say this is your ground level. This is your the surface of the, this is your ground level. This is your surface of the earth. As we move upwards up to a height, for example, if we move at a height Z1, this is what, this is Z1. At a height z, when the temperature of the ambient environment is T1, and then as we move upwards, and for example, at a height z2, for example, the temperature here will be T2. And generally, the case is like as we move upwards, the temperature of the environment tends to decrease. So, this reduction in the temperature, that is T2 minus T1, per divided by the height. Basically, the lapse rate is something. Lapse rate is the change of temperature with respect to the change of elevation from the surface of the earth or at any height. Change of temperature with respect to the change of elevation, that is delta T by delta Z. This is termed as the lapse rate. So for the like for your ambient environment, we consider two types of lapse rate. First one is your dry or dry adiabatic lapse rate, and the second one is your wet or saturated adiabatic lapse rate. So what is adiabatic process? So basically, when we consider the a parcel of air that is traveling from, for example, parcel of so this parcel of air is moving upwards, and you can see that as it moves upwards, the temperature is decreasing. So, what we assume is that this process of this change in temperature, that is adiabatic process. Basically, there is no exchange of heat between this air parcel and its surrounding ambient environment. So, this is adiabatic process. So, we have dry adiabatic lapse rate. So, what is why we say this as a dry? We say this as dry because this ambient environment condition, we are considering that that this is not saturated, the air is dry here, so that is why the lapse rate is dry adiabatic lapse rate. And when we consider like for example, you can see here up to a height of 2000 meters, we have considered the environment as dry. So the dry adiabatic lapse rate will be 9.8 degrees centigrade per kilometers. And above 2000 meters, what we have considered is that that there will be formation of clouds. So what it will happen is the air will be saturated or with the moisture. So that is why the lapse rate here will be wet and comparatively lesser as compared to the dry one. So it will be 6 degrees centigrade per kilometers. Let me highlight this for you. This wet adiabatic lapse rate is 6 degrees centigrade per kilometers, and the dry rate is 9.8, or you can say 10 degrees centigrade per kilometers. Okay, so with this we have we completed the assignment for week 0. Now let's move on to the assignments for week 1. So, okay, so first question is in your class, like in your lectures, you have gone through these kind of various air pollution events or the episodes that happened in the past. So there are some of the events or the accidents or some kind of tragedies that have happened in the past, and you have to match them with the year in which they occurred. So let's see the options. Okay, I think before going for that now, I can quickly tell you a trick to solve such kind of questions. Let's see. For example, see, a few questions back we discussed that this Bhopal gas tragedy will be occurred in 1984. Correct? So the option for B will be 3. So we'll quickly look into that options for this is called as uh, omitting process, option omitting process. So we knew that this Bhopal gas tragedy happened in 1984. So the B will be 3. I guess I'm right. Let me confirm this one again. Yeah, in 1984. It occurred in 1984. Okay. So, yes. So, B will be 3. So, we'll look for those options in which option 3 will be for B. So, it will be either C or D. So, what we knew from this now, ki, ultimately what happened is for A, it will be 1 only. The Great London Smoke will be 1952 because then only will be like it will be there, na? B will be 3. Now we are left with two options, Meuse Valley, Belgium or Vizag gas leak. So, um, yeah. So, I guess, okay. If we know one of the two options now, like either for the Meuse Valley or the Vizag gas leak, since see, we know that this Vizag gas leak is a very current incident that happened. So, it will be like second option only, 2020. So we'll take that option in which D is given as 2, this one. So the correct option will be option D. This is how we match we solve this kind of questions. Like it's not necessary that you should know all the options that are given. You can just have a look at the codes that are given and then you can solve that accordingly. Now, these are the basically I've added these events as per and their years of occurrence as well. Now, next, the gas released during the Vizag gas leak incident was. So, this Vizag gas leak occurred in 2020. It is a very recent accident. It occurred in Vishakhapatnam and the gas leakage was from LG Polymers India Private Limited in RR Venkatapuram village in Vishakhapatnam, and the release it was the release of styrene vapor in the area. So that's the styrene, and the effects were the respiratory problems and irritation in the eyes. The number of deaths were about 12 people, and a lot of cattle also died in this incident, and 585 citizens approximately were hospitalized due to this incident. Okay, so next is the atmosphere is divided into different layers. We all know that. So, the we have to arrange these layers starting from the surface of the earth. Okay, so okay. See, we all know this answer, but let's go for that option approach now. So we have option A 2413, option B 4213, option C 4231, and option D 2431. So for first, initially it will be either 2 or 4. So let's see what is there 2 in 2 and in 4. Stratosphere and troposphere. Okay. So I guess we know that the first layer from starting from the surface of the earth will be troposphere. So it will definitely be first layer. So 4. Okay. So we are left with two options, either B or C. Then, if first one is troposphere, then ultimately second is stratosphere that is given here. So these two are sorted. Then we are left with mesosphere and thermosphere, either 1-3 or 3-1. So what it will be? Troposphere, stratosphere. Then what comes? Let's see what comes next. This is the sequence: troposphere, stratosphere, mesosphere, thermosphere, and then exosphere. So what will come next is mesosphere. So 1. So it will be like 4, 2, 1, and 3. I think option B will be the correct answer. Let me erase that. It will create some kind of confusion to you guys. Hmm. So it will be 4 to 1, 3. Okay, so quickly I'll just summarize these layers of the Earth's atmosphere. First layer is the troposphere. It extends from the surface of the Earth up to 12 to 18 kilometers. And this layer, the temperature profile is like somewhat like if we say as temperature and this. Oh, I am so bad at this. Let's do again. For example, this is your surface of the earth, and this is your height z. So for the troposphere, the temperature tends to, like, it goes from 15 at the surface and then minus 56.5. Basically, it is decreasing. So the temperature tends to decrease. And then in the stratosphere, which extends from 11 to 50 kilometers, it increases again, minus 56.5 to minus 2.5. Then in the mesosphere, which extends from 40 to 40, 50 to 80 to 90 kilometers, meteors are found in this layer of the atmosphere. The temperature profile is again, it is decreasing. Then it is rapidly increasing in the thermosphere because it goes up to 1200 and above that. So this kind of temperature profile is found in the different layers of the Earth's atmosphere. If the range of the air, the range of the scale of air is considered as what kind of, so we have three types of scales of the air pollution: micro, meso, and macro. So in the micro scale, we talk about the like we talk about the area ranging from 0 to hundreds of meters. Basically, if we have a source, a point source here, so in a range of 0 to 100 meter around that point source, if we are talking about the air pollution, then it is termed as the micro scale. Basically, very short range. It can be a building or some closed environment or something like that. That is a micro scale. Then mesoscale, we have three bifurcations: local, urban, and regional. So local level, it lasts for around 5 kilometers in range. Then basically, when we are talking about some area locally, for some sector or some township or something like that, and that is in local range. Um, and then if we have urban scale, and it extends up to the order of 50 kilometers. And for a regional level, it extends from 50 kilometers to 500 kilometers. And then if we're talking about macro scale, that is a very large scale, then we go for either continental level or the global level. The continental level extends from 500 kilometers to thousands of kilometers for an entire continent or subcontinent or a country. Then it is macro scale, and the global scale, it extends worldwide. So the, like, when we talk about the how do we say that, when we talk about these air pollution air pollution concepts, for example, the greenhouse gas emissions, the climate change, for example, the other factors, ozone layer depletion, then these are on the macro scale. So what is okay? So if the range is approximately hundreds of meters, then it will be your micro scale. Now coming towards the next question. So these are some of the examples basically for each type of scale. For the micro scale, we have indoor air pollution and the dust particle emissions. Then for the meso scale, we have photochemical smog, acid rain, visibility, exposure to traffic. These are on the mesoscale, basically that is a local, urban, or regional level. And then coming towards the macro scale, we have ozone layer depletion, greenhouse gases emission, and the global warming as well. Okay, so for the next question, The air pollution pyramid shown here illustrates the inverse relationship between first and second. What is first here and what is second here? So let's have a look at the options. First is the severity of impacts, and second is the proportion of people affected. Okay. Next option is first is the proportion of the people affected, and second is the severity of impacts. Okay. First is the pollution type, and the second is level of awareness. Now, first is the level of awareness, and second is the pollutant type. So clearly, as we see now, um, moment out. Okay. So if we see this now, so this clearly shows that first is the pollution exposure, second is physiological changes, then there we have symptoms of illness, then primary health care problems, like then emergency problems, then hospital admissions, and then ultimately death. So as we move from like bottom to upwards now, so we can clearly visualize that the severity of the impact is increasing. Like, initially, it was just the pollution exposure, and then it is ultimately leading to death. So the severity of impacts is like it is increasing as we move from bottom to up. So I think this will be option first, and I if this is option first, then ultimately the second will be the proportion of people affected, and which is true as well, because a large proportion of people is exposed to the pollution, but as we move towards the more severe impacts, the like proportion of people reduces, because not everyone dies of exposure to air pollution. So this type of pyramid is the air pollution pyramid, which is giving a relationship between the severity of the impacts and the proportion of people affected in that area. So this is like no, this is the severity of impacts, and this is proportion of the people affected. So the air pollution pyramid is a framework that is commonly used to describe the spectrum of health impacts from the exposure to air pollution, and illustrates the inverse relationship between the severity of outcomes. Inverse relationship. As the severity is increasing, the proportion of people is decreasing. That is the kind of inverse relationship that we are having. So next we have the temporary or immediate effects, which are often reversible when exposure ends. These are called as, okay. So we have the options as short-term effects, long-term effects, chronic effects, and none of the above. Okay, so initially I've talked about these like causes and effects of the air pollution. So the basically we have two type of effects that are related to the air pollution. First one is the short term effect, and second is the long term effects. So let's have a quick look on that. Basically, short-term effects are temporary or immediate effects, and these are often reversible when the exposure ends. Basically, the sick building syndrome, if we consider that, for example, if we enter a certain environment and we start to feeling like some kind of nausea or headache or something like that. So those are the short-term effects, because once you leave that place now, you're fine. Like the effects are reversed. So these are termed as the short-term effects, and these include your headache, nose and throat, nose, throat, as well as eyes inflammation, coughing, painful breathing, pneumonia, bronchitis, or the skin irritation. These are all these short-term effects related to the air pollution. And the long-term exposure to health pollutions can aggravate health problems. Basically, the long-term effects include the effects on the central nervous system, like for example, a constant headache or some kind of anxiety. Then we have cardiovascular diseases, then respiratory diseases, like for example, asthma and cancer. So these are all the long-term effects. So for example, if we are constantly exposed to certain kind of environment which have pollution sources, for example, any kind of industry or any workplace that we are going, And also in your households, like for example in villages where women are using firewood for cooking, they have a constant exposure towards the emission of those particulates and gases. So these kind of long-term effects are seen in those situations where we have a long-term exposure to certain type of pollutants. Then they like so we may tend to have some kind of health problems that related to those exposures. Now, next question. An observable alteration in the plant when exposed to the air pollution. This is called as option A, damage, option B, injury, option C, stomata, and option D, none of the above. Um, okay, so let's see what is this. So injury versus damage in plants. So, what is injury? So, injury is an observable alteration in the plant which is when exposed to the air pollution, and initially it appears as a leaf injury and the spot between the veins and the leaf margin discoloration. These are the common types of injuries observed in a plant. And damage is basically economic or the aesthetic loss due to interference with the intended use of a plant. Basically, some kind of if some kind of insects tend to eat your fruits or your leaves of the plant, then that is termed as your damage to the plant. So this is an observable alteration in the plant. Then it will be your injury. Now next is chronic effects of fluoride in animals includes. So basically, what are the acute and the chronic? These are some other kind of bifurcation. Earlier, we took like as a short-term and long-term effects. Now we'll discuss these acute and chronic health effects. So basically, acute effects. Excuse. These acute effects usually occur rapidly as a result of short-term exposures, and these are for a shorter duration, while the chronic health effects generally occur as a result of long-term exposures, and these are of longer durations. So the animals most susceptible to fluoride toxicosis are the cattle and sheep, and then these are followed by the horses, and then it is followed by poultry. So the acute effects of fluoride, these include the lack of appetite, weight loss, health declination, diarrhea, muscle weakness, and maybe death as well. And the chronic effects of the fluoride, these include bone deformity, for example, overgrowth of a bone at certain place, malnutrition, and retardation in the growth. So, what we have asked as chronic effects of fluoride. So, it includes your bone deformity. Now, next question. Which of the following materials is the least sensitive to air pollutants? Basically, among all these options, option A, brick, sandstone, unalloyed steel, and nickel-plated steel. So, among all these options, which of the following material is the least sensitive to the air pollutants? So, the least sensitive material, I guess. Let's see what are the sensitive materials against the air pollution and their range of sensitivities. So these are the affected materials that are generally affected by the air pollutants. Basically, these are the building materials that are used, and we can clearly see visualize this thing like for if we see some older buildings which are constructed many years ago, then after some time what happens is the material that was used that starts deteriorating. So that is the effect of air pollution on that material. So brick has very low sensitivity, then concrete has low, and mortar has moderate to high sensitivity. Then we have sandstone, limestone, and marble. These have very high sensitivity, and these are severely affected by SO2. This is the reason why most of our monuments, which are made of these materials, for example, sandstone, limestone, and marble, so they are like either deteriorating or their color is changing or some kind of effect is being observed on them. And this is the reason why, because these materials are very highly sensitive towards the air pollution, and these are severely affected by the SO2, and which is a very common pollutant that is observed in the ambient environment. That is why these monuments are getting affected as well. Then we have unalloyed steel. This also has a very high sensitivity. Then we have stainless steel, which is having very low sensitivity. Then nickel and nickel plated steel, it also has high sensitivity. Zinc and galvanized steel, this also has very high sensitivity. Aluminium has very low, and followed by copper, that has very low sensitivity towards the air pollutants. So, for example, I think in this we have brick. Brick is the least sensitive to air pollution. Now, in the coastal region, the pollutant which plays a significant role in accelerating the corrosion of metals. So, first one is potassium, second is chlorides, third is calcium, and the option D is none of the above. So, in the coastal region, see what is the among all these, which material is available in abundance in the coastal region, basically, which is there, it is chlorides because of because of the presence of salts in the seawater. Uh, we have chlorides, and chlorides, they play a very significant role as it accelerates the corrosion of metals. And the composition is like sea salts they contain approximately 55% of chlorides and 30.6% of sodium. Then we have 7.7% of sulfate, followed by 3.7% of magnesium. Then I guess we have calcium at 1.2%, potassium at 1.1, and other minor constituents at 0.7%. This is a composition of seawater, which is 96.5% approximately of water and 3.5% salt. And this 3.5% comprises of all these constituents. So I guess chlorides, the answer will be okay. Since we don't have any students in this class because I'm taking this class again. The students, those were present in the week 1. I think no one came today in this class. So we don't have any doubts. I've taken all the questions that were there in the week 0 and week 1 lectures. And if you guys have any kind of doubts, feel free to contact or feel free to come in the upcoming lectures. We have our lecture every Tuesday from 6 to 8 p.m. You can come in that class and we'll take your doubts there as well. So, all right, that's it from my side. Thank you so much. See you.